Okay, this next one is a little bit more complicated because we just have a little bit more stuff happening in the denominator there, but not terrible. So we're looking at the limit as x approaches 0 of that whole thing will give us the derivative of this. So we're looking for, again, that instantaneous rate of change. So this is our f of x. And so again, to find the derivative, we would do the limit as h approaches 0 of f of x plus h minus f of x all over h. So f of x plus h would be 7 over 5 plus, and then here we would just put x plus h, right? And we always want to put it in parentheses, but in this case, we're going to be able to drop those parentheses because there's nothing multiplying on the outside. So this is really just 5 plus x plus h. Okay, so that's going to be the limit as h approaches 0 of 7 over 5 plus x plus h minus 7 over 5 plus x all over h. Okay, so again, the step we're going to look for is we're going to get rid of these fractions in fractions, and so we want to multiply by the common denominator, which is typically this denominator multiplied by this denominator. So in this case, we're going to multiply by 5 plus x plus h times 5 plus x. And remember, if I multiply the top of my fraction by it, I need to multiply the bottom of my fraction. Ooh, this little writing pad is not nearly as neat as it could be, but there we go. So we're multiplying top and the bottom. And again, we're just going to multiply this into this one and then this into that one. Okay. So we're going to end up here with 7, we had 7 over 5 plus x plus h, and then we're going to multiply it by this whole mess here, which is 5 plus x plus h times 5 plus x. Just expand that, right? And then minus, and again, we had this 7 over 5 plus x. And we're going to multiply it by that 5 plus x plus h, and then the 5 plus x. Okay. And then again, all over these multiplied together. So we're going to end up with h times 5 plus x plus h times 5 plus x. So first step is you're going to find the common denominator, which is the two denominators multiplied together, and then multiply it in. Okay. And we're just not even going to expand anything at this point. We will get to the point of expansion after we've gotten rid of the denominators. But for now, we're just going to leave these all just in multiplying together. So then we look and we see, well, I have a 5 plus x plus h up here and a 5 plus x plus h down here. So those actually cancel out. Okay. And then I have a 5 plus x up here and a 5 plus x down there. Those also cancel out. So I end up with 7 times 5 plus x minus 7 times 5 plus x plus h all over that mess, right? And this is where we're going to expand, right? Once we get rid of those denominators, we can go ahead and expand. And when I say expand, I just mean multiply out anything that can be multiplied, right? So combine any like terms, multiply things that can happen. When we have these parentheses, we want to do that multiplication first. So we want to take that 7 and multiply it in first and multiply these in first. It doesn't matter. I could multiply this 7 in first and then this 7, or vice versa. It really truly doesn't matter what order we do that multiplication in, right? But we're going to get rid of those parentheses by multiplying and doing the distributive property. So we take that 7 times the 5 and the 7 times the x. So that gives me 35 plus 7x. And then I take this negative 7 and I multiply it in. And remember, it's going to be each by each. So we're going to take that 7, we're going to multiply it by the 5, the x, and the h. And this is a negative 7. So we're going to say negative 35 minus 7x minus 7h. And I keep wanting to write that x faster. Okay. And so now we're going to simplify where we're going to look and see if there's anything we can combine that's the same, right? So these are both integers or numbers without a variable, right? No x, no t, no nothing, right? So I have 35 and negative 35, so I can combine those together. And when I add those together, they equal 0. And I have 7x and negative 7x, right? So if I go up 7 and down 7, then I end up at 0, right? So this is pretty cool. I end up here with the limit as h approaches 0. And I should have been writing that all along, but you know, why? Of negative 7h over that whole mess. Okay. Now, again, when we get to this point where everything on the top is combined that can be combined, we should be able to get rid of this h. That's the idea, right? If we can't get rid of this h, we did something wrong. Because right now, remember, if I'm trying to evaluate this limit, I go limit as h approaches 0. So if this is 0, then I would get 0 over 0 times whatever this is. But 0 times anything is 0. So I end up with 0 over 0, which is what we call the indeterminate form. It means there's a hole in the graph. It means that that this is approaching from both sides. It's coming in to a specific point, but that point doesn't actually exist. So we're looking at the limit, right? As it gets closer and closer, but isn't quite at that point. So we look, there's an h on top and an h on bottom. So we cancel those two out. And this is, again, where it gets a little tricky. People want to try to mess with the h inside of this term, but I want you to think of this as one big term. If you can't get rid of that entire thing, you can't get rid of any of it. Okay, we don't cancel across addition ever, 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 ever. I always used to joke with my students, it kills kitties. So you just never, ever, ever cancel across addition. So you look at this and you're like, okay, here's one term, here's a second term, and a third term. Okay, and this has two terms up here. And we look at it and say, can we take one of the terms from the top and cancel out one of the terms from the bottom? And we can, right? There's an h here and there's an h there. So we cancel those out and we're left with negative 7 on top. And then we're left with this mess on bottom, 5 plus x plus h times 5 plus x. Okay, now what happens when h goes to 0, right? So as h goes to 0, this is approaching 0. So we do that direct substitution now. We're saying like, okay, what happens if h is equal to 0? Well, if h is equal to 0, then we have negative 7 stays the same, right? So we'd have negative 7 on the top. And then we'd have 5 plus x plus 0. So it's just 5 plus x, right? 5 plus x times 5 plus x. Oh, well, that's 5 plus x squared, right? Because there's two of them. So negative 7 over 5 plus x. Oh, see, and then I tried to write it again the way I just said not to, squared. So this is our derivative. That's a negative 7 over 5 plus x squared. So some of it is just catching that algebra and knowing what to do. But if I had to like list out steps, I would say the first thing is to cancel our denominators by multiplying top and bottom by a common denominator. Okay, so that gets rid of these fractions inside of fractions. Then we're going to distribute in, we're going to multiply in any numbers that can be, and we're going to combine any like terms. Then we're going to look to cancel out that h. That's the key, is canceling out that h. And then once we've canceled out that h, now it's just a plain old limit, and we can just put 0 in for h and see what we end up with.